we have different data security levels. But if the partner, let's say ChatGPT.com is only approved for data security level, say 2, but if the user says, okay, fine, I want access to ChatGPT.com for my application, but I'm going to send data security level 4, it'll deny that. It will deny that. Because it's going to be like, nope, ChatGPT is not allowed to receive data security level 3 or 4. So I deny access. I deny this request of yours. Or we also ask them, are you planning to send merchant data or consumer personal data, etc., etc.? And if that application or if that partner is not approved to receive it, deny access. So not only are we ensuring that the application can talk to only approved partners on the internet, but also only approved data levels and data types can be shared with them.
Hello, welcome to another episode of Cloud Security Podcast. I've got Ramesh here with me. We're going to talk about something really interesting. Ramesh, actually, before we start, Ramesh, could you give a 30-second intro about your professional journey? How'd you end up where you are today?
Yeah, absolutely. Gosh, where do I start? It's been like about 17 years in total that I've been in this domain. I started off as a network engineer. And then right after that, I pivoted into network security, and then I pivoted then into designing and architecting data centers. This is not just from a security standpoint, but also from a virtual machines, hosting, storage, everything. So I moved into that. That gave me a really good understanding of what systems are like. So that was like a great learning experience. And then that's when the entire world in 2016 was pivoting to cloud security. And then I was like, yeah, no, I need to move out of this. I need to get into cloud security. So yeah, in 2016, I helped build one of the first cloud environments, a pretty big retailer. And after that, there was no turning back. After that, it's been completely cloud security and building systems, building applications to secure our cloud environment. And I've been at Block for 5.5 years right now. No other better place to like actually dig deeper into cloud security, to be honest. They've given me the freedom to do all of that. And yeah, that's where I am right now.
And network security would have been an interesting, or network in general would have been an interesting starting point. Obviously, today's topic is the whole egress access control. What are the, I guess maybe before we go to what your talk is, and egress control in general is quite challenging in traditional environments. So just to set the scene, what are some of the typical challenges people come across with egress access controls in traditional environments?
A lot of focus is given to ingress. And rightly, ingress is the point where everyone literally enters your environment, right? But ingress and egress have changed over the years, to be honest. Now, with regards to specifically, and I was actually talking to my mother a few days ago, and she was asking me, "What is your talk all about?" And then I was like, "Look, if a hacker managed to like enter your system, or if a thief managed to enter a house, if they can't get out, you've solved half the problem.
That's
there,
right. Yeah.
You keep the locks safe so that they don't enter. But let's say they enter.
Yeah.
But if they cannot get out, you've solved that problem right there. That's exactly what egress is, right? We talk a lot about ingress. Ingress is absolutely essential.
Yeah.
But what if that's been breached? You want to make sure that no one can get out with your corporate secrets or any of that stuff. And one of the major challenges today is that people don't look at egress. That's one of the largest challenges.
Yeah.
People look at ingress more often than not. But look, also the other problem here is that egress has, with ingress, perhaps you could have like singular points.
Yeah.
Egress is not the same. Egress has like multiple points where you can go out. Ingress, sure, yes. Many organizations are now moving to a particular step where now if you're in the cloud, you can control your exposures and then make sure that your ingress, you have like you can try and map out the path for all ingress. It's not that easy for egress because now you have to understand what are all the egress endpoints, what are the different ways that you can egress. Oh God, the number of ways that you can egress through cloud is unimaginable.
Actually, it's a good point because every conversation is, and maybe to your point, because you came from data center world as well, a lot of them started with firewalls. And I remember, I think at least when I started my career, I was working with a lot with checkpoint firewalls. And I couldn't believe, it's funny because one of the reasons I moved on from that to IAM or other parts of security was because everything was all about what port number, what domain, okay, inbound, outbound, okay, just only inbound. But even then, I think we were primarily looking at inbound because it was the whole idea was I'm going to make a hard shell, like a coconut shell for lack of a better word, that's going to be super, super hard to get in. But you're in, it's just go wherever you want, come out wherever you want. There is like not much. But then proxy happened. There's a lot that happened after that. Is the traditional challenges that we've had with them, they obviously open a Pandora's box for, okay, now that we are there, you can go in any direction. Most people focus a lot on inbound, as you said. There's firewalls, WAFs, all kinds of stuff that people talk about and throw in. Egress controls, does that get even more complex in a multi-cloud environment? We were talking about this the other day as well about it's not just one business, there's multiple businesses. A lot of people acquire, there's M&As, there's all of that as well. Now you're bringing other organizations. Like these days, the complexity to what you're talking about from an outbound connectivity, you're just like, you may think you have made a baseline,
right,
but someone else comes in and go, actually, we have our own baseline. There's another one at the baseline. What's been the trigger point for you to go, okay, I need to, like, traditional approach would have been, hey, by exception, but you didn't choose that path.
Right.
Why go down the path of automating this kind of a thing?
Yeah, look, this is something, to be fair, what happened is that I was working, okay, a short story, right?
Yeah.
I started off at Block as Blocks for Cloud Security Hire, and then right after I joined Block, I became a Kubernetes security engineer.
Right.
I was actually helping our entire build out Block's first Kubernetes platform, Square's first Kubernetes platform. We already had Cache, which had their own Kubernetes platform, but it was Square's first Kubernetes platform. It was a huge platform. And over there, I helped the team build something known as a network policy application.
Okay.
So what the network policy application would do is that it would automatically pull our egress dependencies, our S2S dependencies from a centralized tool.
Yeah.
We would pull that information and then we would go ahead and deploy network policies at each namespace level.
Oh,
so
okay.
Now, because I helped with this, like about in 2023, December, I came up with this idea. I was like, okay, fine. We did this for Kubernetes for S2S dependencies. Why not just expand this for all of egress, all across Block? So then I did a POC, and then I think management liked it. Very supportive manager and the infrastructure security leads, and yeah, they really liked the idea, and we thought, okay, fine. Because look, Block is in a unique place because we have sources of truth for everything. Lots of things. We have a source of truth for all our applications.
Right.
We have a source of truth for all our partners. It's just about bridging this gap. You bridge this gap, and I knew that we could solve for this problem.
Okay.
So that's how it started. And I was like, okay, we have the source of truth for both. Let's bridge this and enable this as a singular solution that all users across Block can use. So that's how it came about.
Because most organizations are primarily stuck at the source of truth part.
Yes.
Because okay, that's where. Because when we were talking about this, the one thing that kept coming to mind was like, but how do I know that Ashish requested access to an application to be going out to the internet, or the specific port on the internet to the specific domain? I mean, now with AI and stuff as well, it could be like, is he going to? And as much as I don't think DeepSeek is that problematic, but if that was a case as a risk posture for your organization, that, hey, we don't want any AI domains to be accessed from here, which is again an egress problem. How do you manage that across, because people are using proxies, whatever, to what you said here, it's definitely interesting. How did you expand that to the broader organization? And is that more from a compute perspective because you already had the source of truth? Or was it more from like the traditional, I know the firewall rule, I know the inbound. Like, what was the approach you took to start bridging the gap and using that to expand on to, hey, how do we do egress access control at scale? Yeah,
look, first off, I want to make it clear that this egress access control is specific to production environment, not for laptops. Okay, because laptops is probably a different problem altogether.
Yeah.
Egress from there is you have like local proxy clients, etc., etc. That's not this, but this is specifically for applications in production talking out to the internet.
Yeah.
That being the case, essentially, like I said, these sources of truths, sometimes plans just work.
Yeah.
You know, you come up with a design and it just so happens that stuff clicks. So that's essentially what happened over here. Because like I said, these sources of truth were there.
Yeah.
And then I was like, okay, fine, we need to build a system which bridges this gap. But the biggest problem was, how do we identify application? Right?
Yeah.
What you spoke about. If Ashish wants to access a particular application out on the internet from production for an application that they own, how do we identify that application? Because that application can now live in AWS, can now live in GCP, can now live in our data center. And now AWS, we have certain environments which might have, for example, Kubernetes. Now our Kubernetes platform will have a particular type of egress. Now our cloud environment will have a particular type of egress. Native services, like for example, EC2, Lambda, and stuff like that. And then now you have data center. It has its own egress. You have firewalls on our own servers, like software firewalls.
Yeah.
They have their own egress paths. So the idea was like, this can get really messy. This can get so messy that at any point in time, and look, here's another problem. Generally, organizations today go ahead and they've shifted left for egress access, which is a great thing to do, right? Where now users, if they want their application to reach out to certain applications on the internet, users go into that repo and then say that this is my application, I need access to this. It's a GitOps fashion. It does not scale at this scale. That blocks scale, because now you have these vast different environments. Do users now go into like GitOps style for each environment? That's going to be crazy, right? And for us to maintain governance over all of this is crazy. So how do we ensure that any application at prod can go ahead and talk to something out on the internet by centralized governance? This is where we use our application identity, which is SPIFFE IDs. SPIFFE IDs basically provide us this rich context of an application, about an application, where it exists, which business unit, who are the application owners, which region, what infrastructure, what more information do you need? All our system now does is, it's now bridged this gap, got the information about the application, it knows where the application exists, and it knows for that business unit what is the enforcement endpoint. And that's it. So long as we maintain that mapping of application to domains, problem solved.
So the person requesting for application access, you have the source of truth for the application.
Correct.
And you have the enforcement point as well.
Correct.
What happens to exceptions?
So in this case, there is no such thing as an exception. Here's the thing, and here's the beauty of the system, right? Earlier on, users would need to request access to certain domains and they were not treated as exceptions. Because if you need access to a domain, you have access to a domain. That's it. There's no rolling back after some time. There's nothing to say that, okay, fine, this is a risky domain, so you cannot send it. Even if you do want to send it, you can only send it for a particular amount of time. For example, there might be legitimate use cases for something like Pastebin, right? Sounds bad from production, but there might be legitimate use cases, so you need to have exceptions for that. We thought about all of that and we were like, and we already had a system in place. Our centralized source of truth, users would go into that centralized source of truth and say, my application needs to talk to this domain. But there was no way to actually confirm that the domain is a legitimate domain, if the domain is from an approved partner, and if this particular, and this was only for one system. And then we had like many such systems.
So I think, so you're talking about the number of systems that were out, because the way I see this as well, one of the biggest challenges a lot of people have is, even with the cloud security alerts and stuff as well, which is, I know it's slightly deviating from egress control, but essentially the challenges people had there was they didn't know who the owner was. But with your SPIFFE ID, sounds like you have an understanding of what the application is, who the owner is, what the enforcement point is. So going back to your Kubernetes statement, or even a VMware or virtual machine or serverless,
regardless,
they're all mapped. So at least from that perspective, you're able to quickly make an assertion for, okay, if there's an exception, or if there was going to be an exception, it should have already been in there.
Absolutely.
Because you would have accounted for that at some point.
Correct.
What about retiring some of those? Or, because I imagine systems go up and down, or not just going up and down as in availability, but more in the context of, oh, now we moved on to containerized. We don't use virtual machines anymore. So what happens in those kind of scenarios? Or does it still stand the test of time?
That's a really good question. So at that point in time, what happens is that the SPIFFE IDs will be retired. So like I said, we have a centralized source of truth, which is known as registry. And it maintains a catalog of all our applications. And it's the one that mints the SPIFFE IDs as well. It mints the SPIFFE IDs. So our system over here, which is the that we've built right now, the egress access, network egress access system, pulls from that source of truth. So when a user goes ahead and requests access to a domain out on the internet for their application, the system automatically pulls a SPIFFE ID from that source of truth. And because it automatically pulls it from the source of truth, what happens is that at any point in time, if that SPIFFE ID does not exist, it'll be taken out of the system. So for example, let's say the infra is, say, I don't know, just some legacy infra, right? And our SPIFFE ID has that infra. But let's say that infra no longer exists, that SPIFFE ID will no longer exist. So if the SPIFFE ID no longer exists, then it'll automatically get updated in the system and you're good. It'll not get deployed into that area.
So now that you explained what was the method to solve this at scale, how does one request access to new egress
Yeah.
a new outbound.
Absolutely. So like I said, we have like multiple business units, right?
Yeah.
Like one business unit goes to a source of truth for requesting access.
Yeah.
Another business unit users go to another and they request access.
Yeah.
And then there are others where that might not exist, right? Whatever. Now we just have a centralized UI.
Okay.
It's just one singular UI right now. Users would go to that UI,
Yeah.
and then in that UI they will search for the domain,
Yeah.
say chatgpt.com.
Yeah.
They search for that domain. Over here in our new system, domains and IP addresses are first-class objects, which means we treat them in a way that they require maximum sort of security.
Yep.
The way that, because we made it first-class citizens, we're now able to do interesting things about it. So now what happens is that because we have a singular UI, users just go and search for that domain. Once they find that domain, then they request membership to that domain.
Okay.
So it's like a group management system.
Yeah.
Let's say github.com is a group.
Yeah.
And let's say that's a file maintained in our repository.
Yeah.
Written into github.com file will be the SPIFFE IDs for each membership request. If it is approved. So user go into that UI, they find chatgpt.com. When they search for it, they're like, okay, fine, I found it. Click on it, go into it, and they type in their application name.
Yeah.
The system will automatically populate it because it's connected to our application source of truth.
Okay.
So you just type in the name of your application, it auto-populates.
Yeah.
And then you say, okay, fine, grant me membership to chatgpt.com.
Yeah.
Not before defining what type of data you want to share with chatgpt.com.
I was going to say.
We're going to clearly say, we're going to ask the users, what data security level you're planning to share with chatgpt.com, and what data types are you going to share with chatgpt.com. And our second source of truth kicks in over here.
Yeah.
Our second source of truth is our source of truth for all the partners.
Yep.
It has clear information about what data security levels they are approved to receive, what data type they are approved to receive.
Yep.
These two sources of truth, this system bridges these two and then says, okay, fine. When a user says, I'm going to send DSL level, we have different data security levels. But if the partner, let's say chatgpt.com, is only approved for data security level, say 2, but if the user says, okay, fine, I want access to chatgpt.com for my application, but I'm going to send data security level 4, it'll deny it. It'll deny it right there. Because it's going to be like, nope, ChatGPT is not allowed to receive data security level 3 or 4. So I deny access. I deny this request of yours. Or if we also ask them, are you planning to send merchant data or consumer personal data, etc., etc. And if that application or if that partner is not approved to receive it, deny access. So not only are we ensuring that the application can talk to only approved partners on the internet, but also only approved data levels and data types can be shared with them. So we're centralizing governance.
Yeah.
Absolutely centralizing governance. And I think this is where our system shines, which is, I don't think, I'd love for your audience to tell me if this is not the case, but I don't think any company out there makes sure that this level of granularity is maintained, in the sense that application A can only talk to an approved partner out on the internet and only approved data types and levels are sent. So this is intentional data is matched against approved whatever the partner is for. If they do not match, deny access.
So every time a new application is being mapped into the system, there is a data classification being added.
Correct.
Because that was going to be my next question about how do you manage the data access parameter, if you want to use that word for this, in terms of what kind of data goes in, whether it's data leakage. There's so many things that are, like with the egress part, a lot of people, and in my mind, when I think about outbound control, a lot more of that is more from a, data breach perspective. The example you gave about talking to him about the story, but the person can come in if they, for some reason, whatever mistake happened and they got in, the ultimate goal for them is to be able to take out the data. That's
C2 access, data exfiltration. Yeah, absolutely.
So that's where I'm like, oh, okay, if you're able to do an automation for outbound access management, so sounds like the basic components that people need to build on that would be having a source of truth
absolutely.
application, what kind of data level that can have, and the other part was the domain that they want to access.
Correct.
So
The
that was
partners.
the
Source
partners.
of truth for our partners as well.
Source of truth to your partners as well.
Yeah.
And you bridge that gap to identify through a self-service portal that
Yes.
which the security team built the first
Yes, my team. We're building.
vibe coding or I will code.
No, we have an absolutely great team out there, which is a part of the infrastructure security team.
Oh.
The infrastructure security team, we have like multiple teams within it, and
Yeah,
we
yeah.
have a great team over there known as the identity infrastructure team. They're the ones who own the source of truth for all our applications, and they're the ones who help build the backend for the bridging system or the network egress access system.
That's awesome, man.
Yeah, and then we have another team which owns the partner source of truth.
Yeah.
So it's essentially like multiple teams within infrastructure and outside infrastructure who came together to build the system. I'm from the network security team. Yeah, I was the one who brought these teams together to do this, but yeah, it was without the infrastructure team's help, none of this would have been possible.
Yeah, wow. Because I think it's funny. The reason I ask that question is because a lot of times where these kind of stop is the network security team would have to go down the GitHub path that you mentioned.
Yes.
It's a very common approach. I've spoken to so many people. I know, because what else can we do is usually the second thing comes out. Okay, we're trying to automate it, but let's just take it to a place where developers know and understand what it is.
Yes.
So they create a request.
Yes.
A pull request comes in, I approve it, but to your point, now times that with 500, 600, then you just have one person full-time sitting and approving or rejecting approves as well.
Correct.
And trying to validate, hey, what kind of data type should I be allowing for?
Yes.
Is there a policy for this? No, there's just so much involved with this.
Which is why bridging these two was like the best thing that we could do, because we were like at that point in time, we don't need any people to be in the picture when users go into the centralized UI and request their access.
Yeah.
Also, we provided a UI to users, unlike GitHub, where in GitHub it's more of a GitOps actions.
Yeah.
Whereas over here, the way is that when a user requests access, the identity infrastructure team built this backend in such a way that essentially any access requests have to be approved both by the system and by owning team members. So if the system essentially does a validation for the type of data that you're declaring that you want to send. And if it doesn't match, it denies the access. But if that's good, a team member of the application owning team has to approve it.
Oh, okay.
It's like Git.
Yeah.
In Git, like you have a team member who has to approve that request.
Yeah.
Something like that. They have to approve that request. But all of these automated actions, we could have done it in GitHub, but we chose not to do it. We figured we'll give a UI to users because now we can put all our governance policies, we can create governance policies around it.
Right.
Singular governance.
Yeah.
And then because we have this singular governance, we can go ahead and do other interesting things of seamless deployment everywhere else.
Interesting. And how does it deal with, so to your point, SPIFFE ID, everything, now we'll bridge the gap, but most people, to what we were saying earlier, they have a mix of compute as well.
Yes.
And Kubernetes is always looked as a data center within a data center. They were talking about namespaces earlier. A lot of people would not even know what namespace is like at the end of this conversation. But in terms of the different types of requests that are coming in, is it because everything is a network level request, that's why you're able to make the same change so easily across all kinds of compute?
Yes.
It doesn't matter what the compute is then. It's asking me for network access, which is a standardized protocol.
Yep.
So all I need is, network connection to port whatever, 15678.
Yes.
And okay.
So here's the thing, right? So there are two things that happen within this system. A user goes in, searches for chatgpt.com or github.com. Let's say they find it, and then they have their membership, their application owners requesting membership to it.
Yeah.
That is how they become a member of that particular application and they get that access granted.
Yeah.
But let's say chatgpt.com does not exist, or github.com does not exist within the system. Remember, these are first-class objects.
Yeah.
We empower the users to now go into the system and create the domain.
Okay,
If the domain does not exist, if
Right.
git.com does not exist or chatgpt.com does not exist, we ask them to go ahead and create the domain. And then the system does the validation again, because we have our source of truth for our partners.
Yeah.
Now the system is able to say that, okay, chatgpt.com belongs to a partner because the system knows it.
Right.
The system knows that chatgpt.com is there in it's OpenAI. That is an approved partner within our source of truth for partners.
Yep.
And it just bridges that. It makes a call to LLM, checks to see that if chatgpt.com does in fact belong to OpenAI, and it checks with the system to see if chatgpt.com is approved to receive this type of data. It does a validation. And
what about subdomains?
Subdomains as well. Every domain is unique. You mentioned ports and protocols,
Yeah, yeah,
etc.,
yeah.
etc. When they go ahead and create github.com, they have to fill out certain metadata.
Yeah.
They have to say github.com, what is a port number,
Okay.
what is a protocol number,
Yeah.
and what is a product ID. The product ID is the unique identifier and a source of truth for
Okay,
partners.
right. That's how it knows.
So
Okay, right.
OpenAI.com will have a product ID.
Yep.
And so the system knows that that's the product ID. So users have to go to the source of truth
Yep.
and enter the product ID for OpenAI there.
Interesting.
And that's how the LLM and the system knows that ChatGPT.com should belong to OpenAI.com and it's an approved partner.
Yep.
So the interesting thing is you spoke about AI, right? Now, let's say we have all these systems which maybe need to reach out to, say, Databricks
Yeah.
or Snowflake or whatever, right?
Yeah.
These AI processing platforms. You need to have tight control over the type of data that you're sharing as well, because your models can also change.
Yeah.
And how we're ensuring. And this is what I was talking about AI, and when we're sharing data with these different AI processing platforms like Snowflake, Databricks, etc., right? Not just that, even LLM. We want to make sure the type of data that we're sending out is
The right kind.
is the right type of
Yeah,
data.
yeah.
Let's say, for example, inadvertently we share secrets over here.
Yeah.
We want to make sure users are purely aware of the type of data these partners are approved to receive.
Yeah.
Where do they go and find that? That'll be our source of truth for partners. They go into that source of truth, which is known as the block software list, which is our catalog of all our partners. And over there, they would go ahead and say that they would look at it to say, oh, ChatGPT.com or OpenAI is allowed to receive DSL data level 3, not 4.
Yep.
Or they're allowed to receive only application type data, no merchant data, no customer data, no customer personal data, etc.
Yep.
So we're now empowering users to put the right information, but we're also validating.
That's pretty awesome. Because I had so many questions about the AI part, but they got answered with the whole data. Because I think the majority of the risk in that context is, in a lot of ways, solved by the network access control and the kind of data that you're allowing. Identity if you can't even get out, then you really don't need to bring that into the picture. Was there a technical challenge that you came across as you're building this, or having a source of truth made it an easier switch?
Oh man, the source of truth made it easier, actually, to be honest. Like I said, not too many organizations out there have a source of truth for their applications and a source of truth for their partners, right? The source of truth is what enabled all of this, to be honest. We've always had this issue where we weren't able to solve for the challenge of how do we ensure we're only talking to authorized partners, approved partners on the internet? And how do we ensure that we're only sharing the type of data that we should be sharing with them? These are two separate problems.
Yeah.
Security, to make sure we're only talking to approved partners.
Yeah.
Compliance, to make sure that we're only sending data that we're supposed to send.
That's right. Yeah.
This was our biggest challenge.
Right.
I didn't think the challenge was to go ahead and deploy policies everywhere.
Okay.
I did not think that was a problem. This was the bigger problem to tackle. And like I said, the infrastructure security team and the InfoSec team, they helped us out with this.
Yeah.
So we realized that we have these sources of truth. I reached out to them, made up a plan, design architecture, and all of us came together to actually do this. And then, look, the biggest challenge, InfoSec teams can do so many things.
Yeah.
But eventually we put this in the infra team stack.
Yeah.
And we need buy-in from them.
Yeah, of course.
It's a huge
Of course, yeah.
Because without buy-in, none of this. InfoSec can do so many things, and then infra teams will just say nope.
It could happen as well, yeah.
Yeah. The way that we're actually solving for this problem is by making sure that we don't even have to trouble them.
Oh, okay.
The way that we're doing this is that, let us assume, simple example, we have an existing system which, say, pulls this information and deploys it into, say, some proxy.
Yep.
We do have that right now. Pulling it from source of truth and deploying it into a proxy. Now, let us say we replace that source of truth with ours.
Oh, okay, yeah, that's right.
Done. That's it. So we're not telling the infra teams, hey, we will go ahead and directly apply this as a policy within your system. But because infrastructure teams may not be super happy with that.
Yeah.
They're like, we don't want you deploying this. It might mess it up. Instead, whatever their current source of truth is, where they're pulling API for their application to domain access, that source of truth, we're replacing it with our source of truth.
That's right.
Because our centralized system now maintains application to domains, mapping in a central repository, their repository, we're replacing it with ours.
Oh,
So they pull it from us, so now every user gets the same UI,
Yeah.
Whatever they request, it goes and sits in the same backend, which has been replaced now.
Yeah.
So the infrastructure teams can pull from this new database and deploy the policy.
And to your point, that's what makes it sure everyone is in sync as well.
Yeah, like our major platforms, I don't think they would. Maybe they will in the future want to directly create their own lightweight modules which can go ahead and deploy it. But for the time being, if we want the entire company to be onboarded onto this.
Yep.
If we want the entire company to be onboarded onto this, we want to make sure the infrastructure teams are not burdened.
Yeah. Yeah.
And the way to do that is just by presenting the same data to them, but this data is now hooked into our system instead of their system.
Yeah.
So now that's how we're bringing everyone together.
Because I think the interesting part over there, as well as you mentioned, is a lot of the times, a lot of the conversation that you'll have stops at the part that, hey, InfoSec, we did so much. We have engineering, we have done all of this, but now the moment you try and get the non-security and the buy-in, that's where, and to your point, probably is, because it is a lot of ask, because they already are doing a lot of things. They already have built systems and everything around it. So they have to, wait, so you want me to stop what I'm doing and now do this thing?
Exactly.
It's a big ask.
Yeah, it's a big ask.
And that's where a lot of people went down the GitHub path as well, because that's the easiest way. Oh yeah, it's already in place. It's just another request. So people are like, okay. It's really interesting. I wonder how many people would be challenging their current thinking about GitHub and all that. So maybe the next question that I have is, then organizations that are trying to implement this, the people who are listening to this belong, I don't know, identity team, infra team, wherever. What is a good starting point to start implementing this in their organization as well?
Like I said, I mean, we're lucky at Block because we have these two sources of truth.
So start with the source of truth first.
I would highly recommend that please have your source of truth. This is a tough thing. This is a tough
Yeah,
ask for
that
organizations.
is a big ask.
This is a really big ask for organizations. Block, we're in a lucky place with Block with regards to this. But yes, you need to have two sources of truth. A catalog of all the applications that you have and a catalog of all the partners that you have approved.
Yeah.
So you need to have these two things. If you had these two things, I think it's easy to build this system.
Actually, that just made me think of something else as well. If a partner has been compromised, I'm just going to call, I don't know, just use whatever example.
Very good question.
Yeah.
I see where you're going with this.
Yeah,
Okay.
so what happens to all the exceptions that have been already put across for the beginning of time?
Very good question. Think about. So this is something that I spoke about during my talk as well, right? This is another place where our system shines. Incident response.
Yep.
Let us say a particular partner comes up to us and says, hey, my particular product, not the entire vendor, but a particular product for that vendor has been compromised.
Yeah.
Now we have full information about every single application that is talking to this partner, to this product.
Yeah.
Salesforce as an example. Let's say Salesforce is a vendor.
Yeah.
Salesforce has tons of services and products.
Yeah,
right?
yeah.
Let's take Slack as an example. Slack now belongs to Salesforce,
That's
right?
right.
But Slack is its own product.
Yep.
So let's say, just an example, right?
Yeah.
Let's say Slack comes up and says, hey, we have been compromised.
Yeah.
The domain is going to be api.slack.com
That's right.
as an example.
Yep.
So just that product has been impacted, not all of Salesforce.
That's right. Yep.
And our system knows that. Our system knows that Slack is a product.
Yep.
And Salesforce is the vendor.
Yep.
So now we're able to immediately, our system, Network Egress Access System, gives us full visibility into all the applications that have access to api.slack.com.
Yep.
And now we can assess risks accordingly.
And turn it off as well?
Absolutely. 100%.
Interesting.
It's just as simple as just removing the SPIFFE ID from the membership. Done.
Also, and then it triggers a workflow which basically takes it off.
And so the workflow, so it doesn't trigger a workflow. So again, this is where we're slightly different from GitOps.
Right.
In GitOps, at any point in time, you make a change and you push.
Yep.
Only the incremental change is made.
That's right.
Whereas our system doesn't do that. Our system treats all of these policies as just policies. It's nothing great. At any point in time, we have it on.
Yeah.
Every 15 minutes, it will pull everything,
Yeah.
deploy it everywhere. Everything. There's no incremental change.
Oh.
Because we don't treat it as something extremely special. It's just lightweight component, just pulls everything and deploys it. It really doesn't matter.
Yeah, I think that is quite key, because a lot of times, and I think this is where the lifecycle management became a thing of its own, because everyone, once you deployed it, you either remove it, but then
There's a lot of management. There's a lot of management overhead here.
Yeah.
You now have to pull that in, check against what the increment is.
Yep.
You don't want to maintain all this. Just pull and deploy.
Yeah.
Make life simpler.
So what would, if people who are listening to this and they go, okay, based on what was shared, it sounds like we need to have source of truth for these things. That start there, even if it's a third-party product or whatever, hopefully API enabled, but whatever the thing may be, use that as a starting point to start pulling. What does that look like from a security policy perspective, egress control, whatever. Now, what would be if assuming they have made the source of truth, what would be different stages of maturity that they can go for? Because I imagine you just can't suddenly start with 25 applications and, to your point, production applications as well. Yes. How do you even start picking the right ones to go for? What's your thinking with if people are trying to implement this? What could be different stages of progression or maturity they can have? What's a good starting point as well?
Excellent question. So the way that we're doing this within our own organization today is like I mentioned, we have like multiple systems. We have multiple egress systems as well. Multiple. Again, the point of the system is to bring all of them together,
that's right?
So we have one system which essentially puts firewall rules for applications that don't want to have dependency over our other egress systems. So it's like a paved path for systems that don't want to have a circular dependency on our existing production proxies. So we started with that. And that's a fewer number of applications, say some 10 or 12 applications. All we did is that now we're starting with this, where we've set like a config file to say that for this type of, we're calling it the proxyless system. So for all proxyless, here's a config file. These are all the applications. So at any point in time, if a user wants access to a particular domain for these sets of applications, the system will identify it.
Yep.
There's all mapping.
Yep.
Where we've also said that we have a mapping for cache, we have a mapping for square, etc., to say that for cache, this is the enforcement endpoint. For square, this is the enforcement endpoint. For proxyless, this is the enforcement endpoint. So we started with proxyless. It's just a very small set of applications versus cache and square, which is like thousands of applications. That can be a pretty big issue if something goes wrong. So we start with proxyless, and then we are now moving in. We're now first deploying it to proxyless, and then for cache and for other bigger systems, once this is successful, we know that the same methodology will work there as well. Only difference is that it's slightly better there because with proxyless, we're directly going in and updating firewalls.
Yeah.
Whereas for the other systems, we're not updating it directly.
Yeah.
We're instead converting it into a data type or database or data store and giving it to them.
Yep.
They're pulling from that data store and going there and applying it. So we're not even touching their endpoints. We're just presenting a new data store to them in this format, application or domain format, presenting it to them and giving it to them. So there are different strategies.
Yep.
It completely depends on the team. I would recommend starting with making sure that you first deploy this to a small set of applications before you move larger. That's like any other design
staged approach. Yeah. And would you want the source of truth to be used by the infra teams before you start doing this? You know how you mentioned that because you want the bind part, make sure that all works. That's the plumbing, for lack of a better word.
Correct.
Make sure the plumbing works before you start adding applications to it.
Correct, yes.
Yeah, okay. That's where the stage approach comes
in. You need to have your sources of truth.
Yep.
Without your sources of truth, you can't do this.
Yep. And I think it's also probably important to have source of truth from a perspective of making sure that if there was a new system, old system, whatever, that kind of becomes that becomes your source of truth to jump onto incident response and who the owner is and all of that as well.
Yep.
That's most of the technical questions I have. I've got 3 fun questions for you as well.
Sure.
First one being, what do you spend most of your time on when you're not trying to solve egress, outbound access management at scale problems?
Yeah, man. My kids, I spend a lot of time with my kids, and like I've mentioned to you before, right? My wife is into compliance and auditing and privacy.
Yeah.
So we spend a lot of time discussing tech and how compliance and privacy fits into tech. So that's how most of the time I spend my time. Either I go out playing basketball with my kids or discussing tech with my wife. If not, I'm playing a nice RPG game.
Oh, nice.
I love RPG video games, and I'm now playing Oblivion. Oblivion is an old game that they've now re-released. Really, just playing that right now.
Awesome. And what is something that you're proud of that is not in your social media?
Oh, something that I'm proud of that's not in social media. My team, the infrastructure security team, they're all rock stars. Super proud of my team.
Awesome. And the final question, what is your favorite cuisine or restaurant that you can share with us?
Oh, man. That's too risky. I can tell you my favorite ice cream shop, though, is a place called Pints of Joy. It's in the South Bay.
So your favorite cuisine, ice cream?
No, I guess my favorite cuisine at that point in time would probably be, like, I'd say Japanese food.
Oh, nice.
I love Japanese food. But having said that, though, I'm a vegetarian, so it's very difficult to get vegetarian Japanese food.
Oh, I was going to say, what do you eat as a vegetarian?
Oh, dude, there are so many. There are California rolls. There are, like, avocado sushi rolls.
Oh, okay.
There are so many vegan options in Japanese food. You're missing out if you haven't.
Yeah, I feel like I'm
Veggie
gonna.
tempuras, I don't even know if tempura is Japanese, please forgive me. But
It is, yeah, and I think the fried stuff basically.
Yes,
Yeah,
right,
yeah.
yeah.
Anything fried is great anyways, but I appreciate you sharing that.
And oh, sorry, one more thing. There's if y'all are in the Bay Area, I recommend you go to this place known as Ramen Nagi.
Okay.
Great, one of the best ramens ever. Vegetarian ramens, best vegetarian ramens
You
ever.
just said vegetarian and ramen together. Oh, wow.
Blasphemous?
If you're saying it's really good, okay, we should definitely check it out and let us know as well. Where can people find you on the internet to connect with you and talk more about it?
Ramesh.Ramani at LinkedIn
Yeah.
and on X at Sekmesh.
Awesome. I'll put those links in there as well. But dude, thanks so much for coming on the show, man.
Thank you so much. Thank you.
Thanks everyone for watching as well. We'll see you next one. Thank you so much for listening and watching this episode of Cloud Security Podcast. If you've been enjoying content like this, you can find more episodes like these on www.cloudsecuritypodcast.tv. We are also publishing these episodes on social media as well, so you can definitely find these episodes there. Oh, by the way, just in case there was interest in learning about AI cybersecurity, we also have a sister podcast called AI Cybersecurity Podcast, which may be of interest as well. I'll leave the links in the description for you to check them out. And also for our weekly newsletter, where we do in-depth analysis of different topics within cloud security, ranging from identity, endpoint, all the way up to what is the CNAP or whatever a new acronym that comes out tomorrow. Thank you so much for supporting, listening, and watching. I'll see you next time.